today we're talking about lab safety, which to me is one of those things that we don't like to talk about, but is so critical and so important. And that's why I devoted one of these workshops to this topic. So, as usual, if you want to ask a question, just go, hit chat, and that's going to be the best place to throw out a question. Just make sure all panelists and participants see it. Is what's selected at the bottom of the chat. Just use that chat. That's the best way to interact with me during the presentation. And then I'll be on to answer questions at the end. So with that, let me get started. All right, so like I said, so today we were looking at lab safety tips and strategies. That lab safety is one of those critical things. And so, like I've said before in previous workshops here, I grew up in Marietta, Georgia, which is a suburb of Atlanta. I have a degree in chemical engineering from Georgia Tech, and then decided I didn't want to be an engineer. Decided I want to be a teacher instead. And so I went to Kennesaw State and got my degree in secondary science education with a focus on chemistry. Started teaching chemistry in 2001. And, some of my time at Kennesaw State, that's where I learned some of this lab safety stuff. And I also learned some of the negatives that can happen. And then I started this company teaching high school chem. The website, the Facebook page, all that started just over a year ago. So lab safety. To say lab safety is important, just one of those understatements. First and foremost, for us as chemistry teachers, we can't rely on our department chair or the biology teacher or the physics teacher to take point on lab safety, because it's just not, the other labs just aren't as dangerous. Like biology, the most dangerous thing you do in biology is using a scalpel during dissection. They just don't have a whole lot of lab safety issues. Physics, the worst thing that can happen is someone drops a weight on their finger. It's like, or when they're dealing with electricity, there's a little bit of risk. But in a chemistry lab, pretty much every time you do a chemistry lab, there's risk, and greater risk than any other science in high school. And so it is critically important because we are significantly more dangerous. And one of my slightly different take on this is that lab safety is not just for students, it's also for you. And I will explain why I'm so adamant about that as we get further on. But, looking at this picture of the student doing a lab here, he's got, a Bunsen burner, so he's got heat, he's got the fire, you got that risk. Then you've got hot glassware. And hot glass and cold glass look the same. Or if you've had it where like kids are dealing with hot glassware and they put it onto a cold countertop and the glass shatters because of the temperature change. Even if it's Pyrex, I've seen it shatter, just going from a hot Bunsen burner to a cold counter, and it cracks. And so there's risk like that. There's test tubes here. Then there's cleaning up these chemicals, and there's what happens if they spill, and all these things come into play. But part of why I say it's important for you is the student, he's exposed to these chemicals for maybe 30 minutes. You're exposed to them every period for a whole day, plus cleaning them up, plus setting them up. Then you get to do it year after year after year. So your exposure to these risks is dramatically higher. And so that's important that you take into account how these risks pertain to you as well as to your students. I saw, it was last summer, there were lots of articles at the beginning part of the summer talking about how students got injured doing labs, specifically flame demonstrations, things involving fire, that kind of stuff, sodium demonstrations. You hear those going wrong. And so we have to be aware of those things, and we got to keep our kids. I think something happening to one of my students would be like my nightmare. Not because of a lawsuit, but just because something would happen to one of my students. So let's talk about student safety first. So to me, student safety starts off with first unit you do every year has to be a safety unit. You've got to go over your lab contract if you have one. You got to go over your lab rules. If you do not have a lab safety contract, the best contract or a good starting place for a contract is Flynn Scientifics. They have a free one. I actually, if you go to Teaching High School Chem /workshop/replay, I have a copy of their lab contract there for you to download. It's a free download from their website, or you can get it from my webpage. But that's a good contract to start with. I ended up taking it and kind of retyped it and modified it to what fits my lab space and kind of my lab philosophy. But it's a good place to start. You also need to go over lab equipment. Like, hey, this is not how goggles are worn. You're going to have somebody who's not going to want goggle marks on their nose, or they don't want it to mess up their makeup, or they've got glasses and they don't want it fogging up, or whatever their excuse may be. That's not a proper way to do that, or they may end up getting to visit this good old eye wash station. If you were at a smaller school like I was, my lab was a Sunday school classroom. And so I couldn't have an eye wash in the middle of the room because we were using space in a church as a private school. And so I had to have the bottle type eye wash, but you got to have eye wash of some kind. It really is critically important in case kids get anything in their eyes. Because, think about it, your skin actually is an amazing barrier to most chemicals. Get a little hydrochloric acid on you, you can take care of it pretty quickly, unless it's like really concentrated. A little sodium hydroxide, you can take care of it. But if it gets in your eye, that's a lot harder to deal with. And that's why eye protection is so critical and why I pitch a fit over it. And so because it's the place where you can get injured the easiest and most long lasting. All right. So I do that at the beginning of the year. Then during each lab, or before each lab or demonstration I do a conversation just for that lab. Because here's the deal. When it comes to lawsuits, and I'm just going to mention this, I know that's not my motivating factor, because my motivating factor is to keep my kids safe. But the whole idea of a lawsuit does come into play here, because if the kid does get injured, what they're looking for in a lawsuit is negligence. Did you do your due diligence to make sure that kid knew what they needed to know to be safe? And doing a lab contract is not enough. By itself, a lab contract is probably not worth the paper it's written on. But if you combine it with every lab, you have the safety conversation, and you're identifying the key hazards in that lab. So like, hey guys, today we're using hydrochloric acid. It is corrosive if you get it on your skin, like depending on the concentration. If you're using fairly weak stuff, like 1 molar or less, then wash it off in the sink quickly, but let me know. If you spill it, let me know so I can clean it up the right way. Don't just use paper towels. You're going through those specific hazards. And it's not just the chemical hazards, it's also the equipment. Are you using burners? Are you using hot plates? Are you using stirrers? What do you need to do to make sure they stay safe? And then also you got to discuss disposal. What is the proper way to dispose these things? Because if you don't say anything, kids are going to dump it down the drain. And there's plenty of stuff we use in Chem Lab that doesn't need to go down the drain. And so we've got to have that conversation before every lab. And if a kid's out and misses it, they don't walk in the lab until they have it with you. You've got to make sure that happens. All right. And so that's critically important that we as teachers are doing that at the beginning of every lab and demo. I do it for demos too. Like, hey guys, I need you to stay X feet away. If I'm doing something that is a little more dangerous, they've got goggles on. If I need to do it under the fume hood, I'm explaining why it's under the fume hood. I'm trying to explain to them what's going on. So, like I said, so hopefully you're not using carbon tetrachloride. That stuff is nasty, nasty and dangerous. It's a really bad carcinogen. But sulfuric acid, for example, is just really dangerous and it really damages tissue. Okay. And then, like I said, the disposal stuff, just teaching them how to dispose and clean up and all that kind of stuff. All right. During each lab, your job is to monitor the room and to answer questions. if your lab setup allows you, if you are helping a kid and you're trying to answer a question or you're trying to help a group with something in the procedure, try to stand in such a way that you're still facing the rest of the classroom. That you don't want to have your back to the rest of the classroom while you're helping one group. I mean, once again, this is just kind of covering your rear. You're just maintaining eyesight. I understand the need to like run to the restroom or go make one last copy of something during lecture, but that can't happen during a lab. It just can't. And so that you've got to stay in there. You've got to stay vigilant. You've got to hold your students accountable. So for me, like one of the ways I did that is I had 2 grades for every lab. So I give them a classwork grade for how they participate and work and follow the rules during lab. And then they get a quiz grade for the write-up or whatever handout they're turning in. And so I'm always giving them 2 grades. One's a classwork grade, depending upon how they act and behave during the lab. And also it's because, once again, we're talking about lab safety. If you're not a big fan of sending kids out of the room, this is one of the places where you may have to do that. My rules, and I let my kids know this, like, my rules, if you start risking your safety or the safety of other people, you'll be in the hall or in the office in a heartbeat. If you're going to horseplay in lab, I'm not going to put up with it. If you're going to, like one of my big staunch rules is you do not touch anything when we walk in the lab until I tell you to do so, or until I tell you to start. So if kids like walk in the lab and start like picking up the chemicals or picking up the equipment, that's their warning, and anything else I send them out of the room because it's just not safe. And so I am a very laid back teacher in general. But when it comes to lab and lab safety, my kids understand that I am fairly strict. And I really try to just hold that line. Because once again, it's not about me punishing them for doing bad. It's about me keeping them safe. And so I'm going to be a lot more serious about that. All right. So also with student safety, it is your responsibility to be the expert on any hazard. Okay, if you are not familiar with an MSDS, a material safety data sheet, or just an SDS, a safety data sheet, you need to learn how to read these. I'm going to show you an example here in a moment of the key parts. They're long, and a lot of the information in there is more for like industrial uses, and so it doesn't necessarily apply to us in a chemistry classroom, but the first couple of sections really do apply to us and what we need to do, because we need to know, we've got to be the expert on every hazard in that lab, and we need to know how to respond. So for example, this is a common chemical that people like to use because it's used in really cool, fun experiments, potassium permanganate. I do not use this chemical because I find it to be too hazardous. So here's the first section. Section 2 lists the hazards. It is a strong oxidizer, meaning it makes things either combust or makes them burn hotter and faster, used in fireworks. It's got acute toxicity, so it's toxic orally, on your skin, or inhaled. It is a dangerous pollutant if it gets into the air. It's also corrosive and can cause serious eye damage. Like all these things make me go, whoa, okay, not a big fan of this. And then here are the hazard statements. Severe skin burns, eye damage. Eye damage, they actually even say it twice. It's so bad. And so it's things like this that, like, when I'm considering using a chemical, I want to check the MSDS sheet. And we'll get to how they should be organized and what you should do with them in a minute. But you've got to check this. And then, to me, the most important section is I can't remember if it's in section 2. I think it's still in section 2, is this one. Because it gives you all of this. Okay? If they ingest enough, this is all the first aid stuff. I always look at the if swallowed thing. It says rinse mouth, do not induce vomiting. Some chemicals you want to induce vomiting, some of them you don't. if they get it on their clothes, they have to go home and get rid of their contaminated clothing. Or they have to go to the gym if they have gym clothes or something. Like they have to get it, and then they have to rinse their skin with water or a shower. Like I remember I was a lab aide in high school, and I spilled some, not potassium permanganate, it was potassium dichromate, but it's got similar warnings. And so like I got some on my shorts. I literally had to check out of school, drive home, take off my clothes, throw those shorts out, take a shower, and then come back to school in the middle of the school day because of these chemicals. And so it's chemicals like this that make me nervous. And if I can find an alternative chemical that does the same thing without me having to deal with this, I'm going to. I mean, potassium permanganate makes some really cool reactions. It really does. So does potassium dichromate. They make really cool reactions. I don't like messing with them. I don't like the level of risk. And it's up to you as a teacher what level of risk you're willing to accept. And so that's why you need to read the safety sheet so you know what the risks are. For example, when I was in college, when I was at Kennesaw State getting my education degree, I was working as a TA in a lab. And thankfully, this didn't happen in the lab I was in. It was a good friend of mine who was TAing a lab, and they were using liquid bromine, which is pretty dangerous. They had it underneath the fume hood where it's supposed to be. They had it in a burette. If you're not familiar with a burette, that's the long, skinny tube with the turning nozzle at the end where you can drip out drops of it. Unfortunately, this burette, the bottom, the stopcock part, could pop out. And so one of the students was using it, and the bottom popped off, and she freaked out and literally put her hands underneath it trying to catch the spill. She had second and third degree chemical burns all over her hands and lower arms. I don't know what I would have done. Thankfully, the professor was in the room. He knew what to do. He was able to take care of it. They were able to get her to the hospital for treatment. But like me, I don't know. I wouldn't put my kids in a place where they were using such a risky chemical. And so, that's a big thing for me. You've got to decide what risk you want to do. And we'll talk about risk management here in a second. You also must model. So that means you have eyewear on. Your goggles are always on. You're doing things the proper way when you do a demo, and those kind of things. And so to me, ways to mitigate risk. One is do a demo. Like sodium in water, I'm never going to let a kid do that, ever. It's just too dangerous. I've shattered a beaker doing that once. And I don't want that happening to a student. So I do it as a demo when I do it. I've gotten to the point in the last few years, I changed schools and I didn't have any in that storeroom, and I chose to just stop doing it. It wasn't worth it to me to order it because I can do a YouTube video about it. Pretty much every chemical reaction you want to do, and any cool ones like Pharaoh's snakes or a clock reaction or something with like lead chloride, then YouTube's great. I use YouTube all the time to show my kids reactions because it's faster, it's safe, it's perfectly safe. I don't have to clean up chemicals. And so a lot of times I'll use reactions with my kids that I know that are safer. And then the big dramatic ones, I'll show them YouTube videos. Once again, it's a way for me to mitigate risk. Or if I'm doing a demo with, like, for example, I don't like using, a lot of people love silver nitrate or lead chloride as a precipitate. That makes lead chloride a really nice, bright yellow precipitate. And a lot of people love that, but it's a pain in the butt to clean up. Because you got to dispose of it a certain way. And if you're not familiar with chemical disposal, Flynn Scientific Catalog has great explanations on how to dispose of chemicals. So you can go to their website and order one of their catalogs. It'll give you every chemical will have a code to a certain disposal method, and then in the back are all the disposal methods that'll tell you how to dispose of it in the proper way. If you're not comfortable with doing a disposal method, you can call your local EPA, whatever they're called, whatever your local environmental groups are, and they'll be able to give you recommendations of companies or other things that can remove chemicals for you for a cost. I had to do that when I was cleaning out a storeroom. Like, there were just so many just really, really old, unstable, nasty chemicals in there, and I had to pay for a company to come in and get them out. But if I'm doing something like lead chloride, and because of the pain in the rear of cleaning it up, I'm going to do that as a demo. Because then I'm limiting the amount that I've made. You know, I've made 5 test tube worths or 6 test tube worths over the course of a day, as opposed to having 10 lab groups, each making it to, you know, so I'd have 60 something versus 6. I cut my waste that I have to deal with disposing into a 10th. And then I let the kids do a similar reaction with something safer. Like, my favorite precipitate reaction is sodium phosphate and copper chloride, or copper sulfate, either one. Because it makes a nice blue precipitate of copper phosphate. The byproduct is going to be either sodium chloride or sodium sulfate, both of which I can filter out and pour down the drain. So literally all I got to do to clean that one up is pour the precipitate through a funnel to filter it out. The liquid goes down the drain with running water just to dilute it a little bit. And then I throw the precipitate in the trash can, and I'm done with cleanup. You know, and so by minimizing the risk, I'm also minimizing my disposal headaches. And so I'm trying to think how to do that kind of stuff. I love doing aluminum and copper sulfate for my single replacement reactions. It's simple. It works well. I like to do calcium and water as a single replacement, showing kind of that, kind of like sodium, but a whole lot safer. It still does all the fizzing and moving around and all that kind of stuff. All right, teacher safety. Key thing here is you have to take your exposure into account. I learned this from my student teaching. It wasn't the teacher I was working, it was the one next door. This is a big high school in Metro Atlanta. But this was a chemistry teacher who was coming to the end of her career. And she had worked as a chemist in a lab of some kind before she became a teacher. But she had been exposed to enough harmful chemicals over the course of her career that she was having health problems and health issues because of that exposure. Here she is coming close to retirement, and her body isn't working the way it's supposed to because of her job and her exposure over the course of her job. And I was like, oh, I don't want that happening to me. You know, and so I'm always very cautious about what I expose myself to, because I don't want it having long-term effects on me. Because once again, my exposure as a teacher is way beyond the exposure that my students are going to get. So it's important for me to take that into account. All right. For our safety, the most dangerous place for us isn't necessarily the lab. The most dangerous place for us is the storeroom. You know, where your chemicals are stored, that is our most dangerous place. And when we're prepping or cleaning up a lab, you know, because we're just dealing with all the chemicals and all that kind of stuff. And a lot of times when you're prepping a lab, you know, that's when you're dealing with the concentrated sulfuric acid or the concentrated hydrochloric acid that you're trying to dilute. And that's, once again, the hazard is higher. You know, are you taking the correct, protocols? Are you doing it the right way? So once again, you should have, and this is actually, at least in the Mississippi, I know, every school is required to have a material safety data sheet on file for every chemical they have. If the Mississippi version of the EPA is the Mississippi Department of Environmental Quality, if they were to come by and do an audit on a school and they did not have an MSDS sheet, then that would count against them. And then they're also looking at storage. Once again, Flynn's got a great free resource. And it's a handout that kind of looks like this. They tell you how things should be organized on the shelves for organic and inorganic and your acids. And they give you some extra tips and stuff. So this is actually, it's a 2-page top and bottom sheet. I've got it, once again, at teachinghighschoolchem.com/workshop/replay. If you scroll down to where this lab safety replay is going to go, you'll see a link to that shelf storage pattern. Okay, and that's also the Flynn address. You just want to get it straight from Flynn, but I also have it on that replay. It's important that things are stored correctly, because if you put two chemicals that don't belong next to each other, and there happens to be a spill, you can have a massive accident. A really simple one is just bleach and ammonia. Bleach and ammonia don't belong together. If they are mixed together, they create a very toxic gas. I can't remember what it is. It's some type of chlorine gas, and it's bad. I had a friend of mine that I did my student teaching with who almost died, and the only reason he and a friend didn't die is because they managed to throw a chair out a window, and then people heard the crash of the glass and came in and pulled them out. And so we've got to be careful how we're storing chemicals. Like chemicals should not be stored on metal shelves. They should not be stored on plastic shelves. They should be stored on wooden shelves. And I mean real wood, not the laminate MDF. And so, those are the kind of things that need to be taken into consideration. Are all your bottles labeled? Like when you take a chemical, like when you take hydrochloric acid and you make a solution, you take it down from concentrated to 3 molar. Did you label it? Did you say, hey, this is 3 molar hydrochloric acid, it was made on this date by this person? Do you have things labeled correctly? Or if it's going into long-term storage, if it's going back into the storage cabinet or storage room, you have a long-term label on it, and those are different. And so once again, that's something you may not be aware of. And so once again, on that same workshops replay page, I've got a link to my file on how to label chemicals. So you should be labeling those. You should be labeling your waste containers. There's a right way to do these. Once again, because I've done this to myself when I've gotten lazy. Because everywhere I've taught, I've been the only chemistry teacher, and so it's easy for me to get lazy, especially with waste containers, and just dump stuff in it and not put a label on it. But then I forget about it, and I come back a week later, and I'm like, what is that? I don't know. And then after I try to think back, but then I'm not sure. So then I have to do some chemical testing on it to see what it reacts with, to see what it is, which is not a good way of going about this. And so it's easy, especially end of the year or end of first semester or end of second semester. You're tired, you're worn out. The extra 2 minutes it takes to write a correct label and stick it on the container feels like too much. But it saves you so many headaches later. Okay. All right, and this is my last big takeaway here. When I took over a science department, one of the first things I did is what I call a lab safety audit. There's not really any good ones that I found online for high school. Most of them that are online are written for colleges. So what I did is I took the ones from colleges and I trimmed them down and rearranged them and made them for high school. And what the lab safety audit does, and it looks like this. So once again, this file is on the replay page. So teachinghighschoolchem.com/workshops/replay. You will also have access to this file. And it's very simple. Like, who's the person doing it? What's their position in the department? The date and their email. And then they go through. And so, is there a hygiene plan? You can find examples of those online. If you email me, I can email you, or I can put on that page the one that I made for the department that I was in charge of. Do you have the material safety data sheet? Do you have an accurate inventory? Do you know what you're going to do about hazardous materials, how you're going to dispose of things? Are all those things accounted for, and do you know where they are? Check or X. If 2 of those things are missing, make a comment. Everybody has a digital version of the MSDS sheets, like it's on a shared drive or something like that. check or X. And then you go through and you're just identifying everything, and it's in these categories. What are the hazards? Are things you have signs that tell what needs to be told? You have labels, personal protective equipment like eyewear and eye washes and things like that. Housekeeping, how you keep things clean, use of the hood, the storage, any biological waste. What are your basic work practices for how you sign up for things? A lot of lab spaces are shared in schools. What are your electrical hazards, emergency equipment, other? And so that lab safety audit goes through all of these categories. And it's one of those things that really right now, the summer is the best time to do it. You go to school, you spend an hour or so, and you go through this audit. And you could probably do it in under an hour, depending upon how good your school is. Most likely, you're going to be deficient in some area. And that doesn't mean you got to freak out and get it done before school starts, but it means, hey, this is something we need to be aware of. We need to be working on a solution. And so that's what the audit's for. It's not there to freak you out. It's there to be a tool to say, hey, where are we and where do we need to be? And then how can we get there? And then you prioritize what needs to happen and what actions need to be taken. Do you need to hire a student worker first semester? If you have those at your school, or if you got some kid who does their work too fast, one of the things you can have them do is they collect MSDS sheets from online for you. You can search for them online and download them as PDFs. And you can have a kid who literally does that for you. Or you can kind of do it during your free time, or you could have your kids do it, make it a family fun day on the computer, hunting down MSDS sheets. I don't know how much your kids will think that's fun, but there are ways to do these things. And so the audit is there to be like, hey, here are some things you need to be aware of. If you haven't done them, do them. If you go through the audit and you have questions about what you should do to fix something, or if you're like, kind of like I've been in some, being part of small private schools, I've been in some odd lab situations. And the question is, how do you make things work? And so, for example, like I said, one of my labs was literally a Sunday school room in a church. And so I had to have the bottles for eye wash. Basically all my chemicals were in one cabinet that had a lock on it, and I put a padlock on it that myself and the headmaster had keys to. And then I had to limit my chemicals because of the whole storage thing. Because they were all in one cabinet, I had to limit what chemicals I had, and I had to limit what concentrations I had of acids and stuff, to make it so that I could store them safely in that circumstance. So I don't think I rarely ever had anything stronger than 3 molar acid in that cabinet ever. And the acids were kept on the bottom, and then, and so I still tried to follow the basic pattern, but I had to adjust it to fit my needs. If you're in a school that's old, my first school was this way. It was an old lab, and we had gotten all this stuff donated from a local school, which they shouldn't have accepted, because it was a bunch of old, crappy, expired chemicals. Half of them didn't have proper labels on them. Some of them I didn't even know what they were. I couldn't tell what they were, other than old and bad. And so if you're in that type of situation, you've got to go through your storeroom. You've got to clean out the old stuff. You've got to set it aside, and you've got to kind of divide it into its groups. And you may have to talk to your principal and say, we've got these major hazards, and we've got to clean this up, and it's going to take some money. Money for you to get paid by the hour over the summer to come in there and do it. Money to have somebody come in and dispose of all of that waste. But if it keeps you safe in the long run, it's worth the time, it's worth the effort to have that conversation. So for me, once again, lab safety comes down to 2 things. Keeping the kids safe, which is having that unit at the beginning of the year where you're going through all the labs safety rules, like no eating, chewing gum in there, you always keep your goggles on, no horseplaying, don't touch any of the chemicals or equipment until I tell you to do so. All of those rules get covered at the beginning. And then you also go over what basic equipment is and how to use it. Hey, here's a beaker. This is a flask. This is a stirring rod. This is a thermometer. And here's how you use it. You don't want your thermometer touching the bottom. Here's how you use a thermometer clip. Are you going through all those things? But even more important than that is before every lab, take the time to sit there and say, all right, we're about to go in the lab. Here are the hazards for this lab. Here are the chemical hazards. Here are the equipment hazards. Like you got to have that conversation. Like if you're using glass over a burner or a hot plate, you got to have the conversation that hot glass and cold glass look the same. And always assume it's hot. And you got to have that conversation with the kids, and not to take it off the hot plate onto the cold countertop, that kind of thing. And so you got to have the equipment conversations, and then disposal conversation. Hey, when you finish, this beaker goes into that waste container over there, but this stuff goes in that waste container over there. None of it goes in the trash can. None of it goes down the drain. You got to have those conversations. If it does go down the drain, if something can go down the drain, I usually don't tell my kids that, because I don't want them to get in the habit of putting things down the drain. And so I tell them to put it in a waste container, and then I'll put it down the drain later. But I just don't want them to get in that habit of putting things down the drain. And then on the teacher side of safety, a lot of it is just planning and thinking about what chemicals you're going to use. What are you going to expose yourself to? What is an appropriate level of risk for you and for your students? For example, the one where I've seen people get hurt is it's a version of the flame test, all the different types of colors of flames that you get from chemicals, which we'll see on Thursday with fireworks, is doing the flame test with methanol, where you dissolve them in alcohol and then light the alcohol on fire. It's just an extremely dangerous way of doing it. There are safer, easier ways to do a flame test. And flame test is one of those things that it's better as a demo than as a lab, in my opinion. Once again, because I can control the risk a lot better when it's me doing it. And then there are some things where I just don't like to do them at all, and I use YouTube. Once again, not just for the student risk, but my own risk. And then some resources on organizing your storeroom, doing this lab safety audit. These are just things that I think are critical for keeping you safe as a teacher. All right. So I've been going through this every time. Just once again, think in mind, especially if we get closer. Some of you just finished. Some of you, you're down to just over a month before you go back, or even less now. And so you need to start thinking about where you are as a teacher. Are you someone who's trying to grow in content, and that's where you need to focus? Because I'm going to talk about that in a couple of weeks. That sets your expectations for the year. If you're here, a teacher who's here, you should have different expectations for what your year of teaching chemistry is going to be like than a teacher who's here who's really focused on how to communicate it. And then someone who's really comfortable with communicating it and they're really trying to grow in creativity, those are just different places. You have different expectations. And I find that when we have good expectations of where we are, or a good understanding of where we are, and that helps us set good expectations for where we should be, which I think really helps us not be too hard on ourselves. Because I think that's the biggest thing for teachers, is that we are sometimes our worst critics. I think that's fairly typical of most teachers. And that's one of the things I just want to help you all with, is not beating yourselves up that way. And that's part of why I kind of have this framework, because it really is helpful to know where you are on this spectrum. Okay. So next week, I'm doing the workshop on reactions. And so chemical reactions are next week. Strategies for doing that. Got a really cool method for doing balancing reactions. And then also why I make my kids predict the products of reactions. And I'll go through why I do the things that I do there and just what I think is helpful there. Right. And then the products that I have, I am looking at rolling out a couple of new options on things in the next couple of weeks. So just kind of be on the lookout for those things, either via email or through another workshop like this, and just trying to lay out everything I can because I'm just trying to find every way that I can serve you as teachers, in every way that I can help you be a better chemistry teacher. And so I'm trying to just think of ideas and come up with things to help out there as much as I can. And so if y'all doesn't seem like there's too many questions today, so I'll stay on for another minute or so if you have any questions. Otherwise, I will see y'all next week when we get to chemical reactions.